Using confidence intervals to estimate population proportions. Recall, the central limit theorem for proportions allowed us to estimate the sampling error for population proportions, provided n was large enough. For our problems, n large enough is fulfilled provided n times the sample proportion is greater than 5 and n times 1 minus the sample proportion is also greater than 5. Provided both of these conditions are met, we can use the formula listed on this slide to estimate our population proportion. If either of these conditions are violated, then you cannot proceed with estimating a population proportion. Since we've had a lot of practice constructing confidence intervals in previous sections, let's dive right in and apply this formula to an actual example. A survey of 800 registered voters in Ohio was conducted to determine the percentage of voters that intended to vote for Barack Obama in the 2008 general election. 480 of them indicated that they planned to vote for Obama. Construct a 90% confidence interval to determine the true population proportion of Ohio voters that intended to vote for Obama in the 2008 presidential election. Recall that we can use this formula to estimate the population proportion provided these conditions here are met. For our problem, our n value is 800, and our p-value, the proportion of our sample that intended to vote for Obama in 2008, is equal to 480 divided by 800, which is 0.6. So n times p would be equal to 800 times 0.6, which is 480. This value is indeed greater than 5, but also n times 1 minus p, which would be 800 times 0.4. That equals 320, which is also greater than 5. So if we plug our p-value into this formula and plug our n value into this formula, the only thing left is for us to follow the steps outlined in the previous sections and compute our Z alpha over 2 value for 90% confidence interval. If you follow those steps, you will obtain a Z alpha over 2 value of 1.645. If we compute the error section of this problem, we will obtain 0.0285. So our 90% confidence interval will be computed as 0.6 plus or minus 0.0285, or our confidence interval is between 57.15% and 62.85%. So we can state that we are 90% confident that the true proportion of Ohio voters that intended to vote for Obama for president in 2008 is between 57.15% and 62.85%. Let's get hands-on practice with computing confidence intervals for population proportions. Seda County's Board of Education conducted a poll to determine their residents' feelings toward an upcoming education bond referendum. They surveyed 200 residents, and 35 said that they would vote against the bond. Construct a 95% confidence interval for the true proportion of residents that would vote against the bond. You should pause the video at this time and try to complete this problem. First, you should have started by verifying that n times p is greater than 5 and n times 1 minus p is greater than 5. In order to do this, we compute our sample proportion as 35 divided by 200, which equals 0.175. Then, you should have computed n times p, or 200 times 0.175, and verified that you obtained a value that exceeded 5, and also n times 1 minus p, or 200 times 0.825, and verified that that also exceeds 5. Once you verified these two conditions, you should have plugged your p-value into the equation and n value into the equation, and then you should have computed your Z alpha over 2 value for 95% confidence to be 1.96. Computing the error section of this equation, you should have obtained 0.053. So our confidence interval should be constructed as 0.175 plus or minus 0.053, or the interval should have went from 0.122 up to 0.228. So we are 95% confident that the true population proportion of residents that will vote against the bond is between 12.2% and 22.8%. A poll like this could be used in order to determine if there is a large opposition against a referendum. In the event that this poll showed that there was a very good chance that their referendum would not pass, they could use this as evidence to justify why they should spend a lot of money in advertising and campaigns in order to convince residents to vote for the bond. Just like when we were working with estimating population means, sometimes when we estimate a population proportion, if the sample size was too small, we could obtain a margin of error which is unacceptably large. In the event that our margin of error is unacceptably large, we can determine the number of items that we need to sample so that our maxed margin of error will not exceed E. The formula for doing this is provided here on this slide. On this slide, our E represents the max margin of error that we desire. We should note that this formula requires a preliminary estimate of the value P. In the event that a poll has not previously been conducted, in order for us to have an estimate, we can always use the value P equals 0.5 as an estimate for this formula. This estimate will cautiously allow our sample size to be increased. For our previous example with CETA, the poll that they conducted to determine the proportion of residents that will vote against the bond referendum, we found a sample proportion which was margin of error which was equal to 0.053. Suppose we decided that we want this margin of error to be 0.03 or less. The question is, how large of a sample should we have sampled in order to meet this required precision? At 95% confidence, our Z alpha over 2 value is 1.96. Our p-value for this problem, since we do have an initial investigation which produced a sample proportion for us, that p-value is 0.175. 1 minus p is 0.825, and the max error that we want is 0.03. So if we plug those values into this equation, we will obtain 616.26. So we should sample at least 616.26 people, or 617 people. Notice, when we sampled only n equals 200 residents, we had a margin of error of 0.05. However, by increasing this sample size to 617 residents, our error would be reduced to below 0.03.